Last time, we talked about GPIO outputs configuration and control. Let's now talk about inputs. Digital inputs are used everywhere. Just look around and you'll find dozens of examples where inputs are used. Smartphones, white goods, computers, literally everywhere. Digital inputs are used to handle switches and buttons, but not only. They can receive digital signals coming from other components like knobs, encoders, MEMS sensors. This is why it's so important to cover this topic. We have to allow users to somehow interact with our board. Before we start configuring inputs in our application, we need to again have a look on the GPIO schematic diagram, same as we did it when playing with outputs in the previous video. If you don't know how to configure outputs, you should definitely pause this video and watch the previous video about GPIO outputs first. As you remember, GPIO pin can have 4 different modes: inputs, outputs, analog, and alternate function. This time we will take care of digital inputs. So, when the I/O port is set to input mode, few things happen around our pin. The most important, the Schmidt trigger input is activated, and from now on, this component uses pin input voltage to determine input state. Input data register holds input state value determined by the Schmidt trigger. What is more, its value is updated with every AHB bus clock cycle. So in our case, it is up to 100 million updates per second thanks to 100 MHz source clock frequency. Additionally, pull-up and down resistors are activated depending on the value in the pull-up, pull-down register. It is also worth mentioning that the output buffer is disabled, and writing any value to output data register is pointless as it has no effect at this point at all. Now, our BlackPill board comes with 3 tact switches, one of which is free to use by the board user. It is a small component labeled as key. Looking on the board schematic, we find out that our switch is connected to PA0 pin. It is also connected to the ground, and it means that whenever the key switch is pressed, the PA0 input state will be low. And now the question is, what is the input state when the key switch is released? There is nothing between the switch and the input that can set the state to high, and that's where Pullup Register comes in. By enabling the Pullup Register, we get a high state on the input whenever the switch is released. So once again, we get a low state when the key is pressed and a high state when the key is released. With knowledge about how to set up and control outputs on our BlackPill board, setting inputs is very easy and requires just a few lines of code. To configure the GPIO PA0 pin to input mode, first we need to enable the GPIOA port. This we do by setting GPIOA enable bit in AHB1 enable register. Next we have to set pin mode to input. As we remember from the previous video about GPIO outputs, pin mode is set using model register by writing 0-bit value to proper bits. For pin PA0, these are bits 0 and 1. Additionally, we have to enable mentioned before Pullup Register. For this, we'll use Pull-up, Pull-down Register. Enabling Pullup Register for PA0 pin is done by setting bit value 1 to bits 0 and 1. Now that we configured our input, we can get its state by reading bit 0 value from input data register. To demonstrate that everything is working, we'll make a small application that controls the user LED depending on the switch state. And so, the LED will turn on whenever the switch is pressed, and the opposite. The LED will turn off when the switch is released. Let's do it! Let's build the application and run it on our board. Perfect! Everything is working as expected, and now we have control over both digital inputs and outputs. Let me know in the comments how do you use digital inputs. Thanks for watching, and I'll see you next time.